Okay, so graphing inverses. With inverses, we know that we switch our x and y. So the only thing we have to do here is graph our original. In this case, is a linear. So this is y equals 3x minus 5. We start our line at negative 5, a slope of 3, so we go up 3 over 1. When you're graphing these, you want to do them as precisely as you can because you have to switch the x's and y's. Illustrated with me. So line it up, draw your line. That's your original. So if it were written in f of x form, this is your original f of x. So then when you do your inverse, you're swapping all your x and y's. So if my y-intercept here is the point 0, negative 5, then my x-intercept is going to be negative 5, 0. And if my point right here is 1, negative 2, then it's going to be negative 2, 1. And if this is 2, 1, it's going to be 1, 2. So you should be noticing this pattern here is going up 1 over 3 instead of up 3 over 1. Whoops. So I need to graph that line. And it also wants to know the equation of that inverse. That's the f negative 1 of x. So my equation for that line, my y-intercept is, Oliver, shh. My y-intercept is 1 2/3 is where it ends up. So my apologies for that one. But my slope is going to be up 1 over 3. So my inverse is 1/3 x plus 1 2/3. I wouldn't, again, expect an inverse, or expect a fraction 1 on your final, but there it is. Any questions on that one? So graph your original, graph your inverse by swapping all the x's and y's, and then write your equation. Hopefully you guys are recognizing that knowing how to do those graphs is really important. That's pretty foundational to everything you need to be able to do on this test. Graph of an exponential and inverse. This was on worksheet AA 3-3. So on this one, y equals 2 to the x, you have an exponential equation. So if I look at this in terms of a table, and you don't have to because you can figure out, some of you can figure out just fine. If I have x to the negative third, 2 to the negative third, that's going to be 1 over 2 to the third, which is 1 over 8. As we get further negative, gentlemen, go away. Stop talking right next to the video. Oliver, shh. So, negative 3, 1/8 is going to be one of the points there. As we get further negative, it's harder to graph because it's so close to the x-axis. Negative 2 is going to be 1 over 4. Still very close. Negative 1 is going to be 1 over 2. 0, anything to the 0 power is always going to be 1. This point right here is one of the very important ones that you need to be able to graph. Anything hitting a grid line you need to be absolutely clear with on your graph. 1 is going to be 1, 2, because 2 to the first is 2. And then 2 to the second is 4. And if you want to go one more, 2 to the third is 8. So if you go for this exponential curve, you're going to go as close to that, to what turns out to be an asymptote, as you possibly can. And then you also need to draw the asymptote. So you have an asymptote at y equals 0, because there's absolutely nothing that you could put in for x that would make y come out as 0, because no matter what negative numbers you use, you're just going to get tinier and tinier fractions. And any positive numbers, obviously, are going to go up a lot faster. Any questions on that graph? Damari, go to class. So, highly proficient on this one, you need to be able to prove that this is the log of the inverse. That's the log function. So that was another one we did on that worksheet. So that is the graphs of, so that's the graph when we're looking at inverse and its original. They're always going to be reflective across that y equals x line. You need to make sure to specify the points that are there. If they're asymptotes, those need to be clear as well.